Okay, so today we have a Wells Gardner K7500, and it turns out that this is actually the second time that this has been across the bench. I have repaired this previously and sent it off to the owner, who put it in a 720 machine, who then sold that machine to somebody else. During the transportation process of the machine to its new home, something happened with the monitor or chassis, and it failed to operate when it arrived at its new home. And it failed in rather spectacular fashion, easy for me to say. And we got to figure out what's going on with it. So I had repaired it previously. I don't recall what was wrong with it, but this is absolutely one that I repaired previously because I looked it up and I found the person I had sent it to originally. I replaced the R104 here. That's one of the ones that I replace. It's, as a matter of fact, if we look here, I've actually got a bin of parts. And if we look at this resistor here, you can clearly see that I've still got one left over here from my sources of parts. So it's the same exact one. So also I go through and I put I'm the only one I know of that puts the Sharpie mark across all the caps when I change them out. So this is absolutely 100% one that I have previously worked on, but because it was put in a machine and sold and now it has a new owner, something happened to it in transport and now it's dead again. And some of the keen observers here might have already spotted the problem. Look at the switch mode power supply chip has exploded. Just completely exploded here. I don't know what in the world would have possibly caused this. I've never seen anything like that before. It just exploded. Big burn mark on the side of this cap right there. So I can only assume that there was a loose screw or something going on, because there's some kind of jury-rigging deal going on here with mounting this. I don't know what the purpose of this is. I don't know what's going on here. So I don't know if this thing slid. I don't know if it slid over or fell out of its casing or what happened, but it got damaged from shipping and U101 exploded. So we got to figure out what caused that and get this up and running again. Now, somebody, let me see here. Let me rephrase, I'm sorry. The person who owns this and sent it to me did not send me the remote board that normally hooks here, but fortunately I have a spare here for just such an occasion that I keep on hand, so we got that. But we need to try and figure out what's going on with this. It's very clean, like it's got an unbelievably low amount of hours. Original flyback, but it's already been capped and reflowed and everything. I replaced R104, possibly due to something wrong with the power supply from the last time. And it's not exploded or butchered or blown up on the bottom. So I have to assume something was laying on the chip when it got turned on. I can't say, but we'll have to go through and figure out what's going on. So the first thing we need to do is actually just remove the chip and then verify that the cap next to it that's charred isn't shorted. Make sure other components aren't shorted. So we'll have to remove the chip, put a socket in, replace the chip, and then pull out L100 here and do our light bulb test and see if the power supply operates. If it does, then we'll fire it up and turn it on. Maybe there's nothing wrong with this except something was laying on the chip and it blew up, and replacing it might get it right back up and running. If so, that'd be great. But if not, we'll troubleshoot further. So first things first, we'll have to take that chip out, check the components around it, put a socket in there, replace it, and then do our light bulb test and see what happens. So let's get that done first. All right, so I got the old U101 out, the exploded one here. I don't even know if we can see it. I won't focus on it, but there you go. And I got that out of there and put a socket in and a new chip. And I went through and tested some of the components here, and everything checked okay. Nothing was shorted. I took L100 out. I have not tested it yet, but in poking around and testing other things, I tested R104 again to make sure it was good. And I tested the MOSFET here, the Q101, and the MOSFET is shorted. Not only is it shorted, but it's got a broken pad. Now, I would not have sent this back to the owner in this condition, and obviously it wasn't in this condition when he sold the machine. It was working. Something happened either in transport or somebody else was fooling with this. It shouldn't have been fooling with it. I don't know. I have no way to find out, but if we go to continuity mode on our meter and we touch the pads here for our MOSFET, negative on the top in the center and each outer leg, we get dead short and dead short, zero ohms. It reads 0.3 ohms and 0.4 ohms. So our MOSFET is shorted. But not only that, it's got a broken pad. I'm not sure if you're going to be able to see it, but the pad is broken. If we tap on the pad here, I'm not sure if you're able to see. I just noticed it from testing, but the pad is actually broken. I don't know. I don't know if you'll be able to tell. Let me see if I can get this off of here. Yeah, see, the pad is actually broken. Can I get this off of here? Yep, see? Let's use this. Yeah, there you go. So I don't want to lose it, but there it is, right there. And you can see that it's gone. So I don't want to lose that. So we'll set that aside because I need to solder it back on when I change this out. But let's get that MOSFET off of there. So, I mean, with a shorted MOSFET, that could explain why this exploded. That's the only thing I could even imagine as to what would cause this to blow up like that is a shorted MOSFET. And sure enough, it's shorted. So let's just go ahead and get this off of here. I've got plenty of parts chassis to steal this off of. So whenever you have a problem like this, you always want to verify by removing the part and then testing it out of circuit to make sure that it's not something on the chassis that's causing the pads to reach shorted, or if it's the actual component that it is in fact shorted. And let's finish desoldering this. Now the other one, what? This one's broken too. I can't believe it. Look at this. Both of these MOSFET pads are off, are broken. Look at this. There's the other one. How in the world, somebody had to have been messing with this, because there's no way that I did this. I mean, I worked on this chassis previously, there's no doubt. But I would not have, I didn't remove the MOSFET. I reflowed it, but I did not remove that MOSFET. So somebody, I think, was probably trying to troubleshoot this for some reason or another. What in the world? Look at this. Oop. Look at this. Somebody was definitely messing with this because they have lifted this pad. Look at that. That whole thing is, someone pushed on this cap and they lifted that leg there. Yeah, look at that. Somebody who was doing it, somebody was messing around with this. It was not me. I did not send this back to that person in this condition. We're going to have to use a little super glue or something on that to fix that, but that's secondary. Let's finish this last. Are all three of them broken? That one's lifted slightly, but it's intact. Let's verify. Yeah, that one's intact, but I think I'm going to shave a little bit off of it. I'm going to remove this neck board also so it's not constantly in our way. Alright, so that's out of here. All right, well, let's get this MOSFET off of here. This has never been removed. It's still stuck to the frame. You want to be careful when taking these out, you don't damage the insulator. But now that we've got that out of there, let's test this for short. And 0 and 0. So, shorted MOSFET. What could have caused that? Well, let's throw another one in there. I've stolen that one already. I got a donor U5000. Let's steal this one. All right, let me take this one out and I'll come back and we'll have it installed in this one. And just like that, I got the new MOSFET installed, or the replacement I should say. We got it stolen from the donor chassis right there and installed in our one that we're working on here, and let's go ahead and test it now. So as we saw before, it was shorted, and I actually I got the pads reinstalled, and I had to scraped a little bit of the trace away and soldered directly to the trace, so it should be nice and secure now. So if we test it now with our replacement MOSFET in there, we should get 0.5 voltage drop to, I believe, the bottom right, and around 1.0 to the left. So it's been a while since I've tested this, but center on negative with diode checker, the right leg should be about 0.5, 0.499, and 1.0 something or other. Yeah, 1.0. So we definitely had a shorted MOSFET, which absolutely could destroy U101. I just hope nothing else is taken out. Yep, still shorted. So, all right, we'll set that aside with our destroyed U101, and let's put this donor U5000 out of the way. And now that that's done, let's go ahead and try our light bulb test, because light bulb test would absolutely not work with a bad U101 or a bad MOSFET. And you know, I didn't really even think about it. Let's test. I think I did test this. I can't remember. It's been a few minutes. Let's test this. This should be 10K. Just to make sure that we're not going to blow this MOSFET up again. Yeah, 10K. All right, so we're good there. All right, well, let's see if our light bulb test works. I got it buried over here somewhere. Here it is. Buried over here somewhere. I think this light bulb is actually... You know, I think this light bulb might be bad. The last time I think I did a video a number of months ago where my light bulb was bad. But let's just see what happens. Maybe I'm wrong. Okay. All right, so L100 is out. Let's hook our lead onto here, and it should light up. Let's turn it on. 1, 2, 3. Oh, I can hear the power supply hissing. Look at that! Awesome! Love seeing that. Okay. So now that we tested that, let's go ahead and discharge it. We can take a lead here and touch the frame. We should discharge the stored B+ in the power supply. Here we go. Okay, it's already dissipated. That's good. All right, so hopefully the only thing that was wrong with this was a shorted MOSFET that took out U101. What would cause that? I don't know. I hope they didn't try and run it without this hooked up, since they didn't include it in the box. I'm hoping they didn't try and run it with this unhooked. But like I say, this was sent to me before. I fixed it, sent it back to the owner. He put it in a 720. It worked fine. And then he sold it to somebody else, and when he got it, it didn't work. So that's why I'm skeptical of somebody messing with this, because, you know, 2 of those solder pads were completely broken. Now, how could that be? If this is secured in here and untouched, how did 2 of those pads get broken unless someone took it out and tried to mess with it? I'm very skeptical, as well as I don't know how through handling this could have got... I need to glue this back down. So now that I'm thinking about it, I'll have to do it. I'll do it right now. Well... Oh, my package is here. Stand by. Well, 2 of the 3 things that I've been waiting on arrived, so it's better than nothing. Sorry about that. Okay. Well, let's get some super glue under this lifted leg here. And don't need a lot, so I think our best bet is to lift that up a bit. Just a dab will do ya. And that should work. Hold it there for a bit. I'm going to hold this for about, I don't know, a minute or so, and I'll come right back. Alright, so that's done. Let's get L100 back in place so we don't forget to do that, because I always seem to somehow forget that. Then I lose it. Here it is. Alright, now I think that's it. I guess we'll fire it up, and I guess what we should do is let's test the HOT just to make sure that we're not going to have any surprises. Upside down, here we go. 0.45 and 0.45. Okay. Well, I have absolutely no idea what could have caused that MOSFET to short out, but it's almost certainly the cause of U101 exploding. And now that we know our light bulb tests okay, our power supply section should be back to working. And let's put it on a tube and see if it works. The neck board is in phenomenal shape. Like I say, this is a very low hour 7500. It's not really hardly even any discoloration. I've already done reflowing and stuff like this, so I'm just 99.9% sure that somebody has gone messing around with this MOSFET trying to fix the problem. I don't know. I can't say with 100% certainty. I'm fairly certain the person that sent me this did not mess with it, but I don't know from before they got it what was done, because they told me that it was sent to them in working condition. When they got it, it wasn't working, and they turned it on and it didn't work. But I don't know. There were two of the three pads here were lifted and broken off the traces, and it never would have worked when I tested it, and it never would have worked to one of the person I sent it to when they tried it. So I think somebody had to have been messing with that. I have no other explanation. But let's get this back on here. Get this on here. Get our focus wire back in there. And let's get our temporary remote board plugged in. Okay, now I think I have the transistor. I do, but not on my test tube here, so I'm going to have to get, I think my spare transistor is hanging out in here somewhere. I don't see it. That wascowee wabbit. Where is... Because the K7500 requires... Yeah, I don't know where it is, dang it. There is a transistor you have to hook up to this connection here. Normally the transistor mounts right here, but for some reason they remotely mounted it on the 7500, and it attaches to the frame right there, and that's what is responsible for controlling your width. If you try and adjust your horizontal size and nothing happens, then you either have a bad transistor or it's not plugged in properly. I've got that sitting around somewhere, and I'll be darned if I don't know what I did with it. Ta-da! Found it. It's right here. So we can take this, and it has to plug in with, not upside down. The connector is very clearly oriented like this. You take your transistor and plug it in like so, and that should give us width control. So let's get this on the tube and turn it on and cross our fingers and see if it works. Well, here we have it installed on the tube. This is a dedicated 7500 tube. It's 25-inch. This is a 25-inch chassis. If we look at the ID label here, it says Wells Gardner Monitors 25-inch 7500. So We are good to go for that. I have B+ set up to read here. We've got ground going to the frame right there, and positive goes right there on that side of L100. And yeah, so if it does turn on, I don't have a video signal. We're only curious to see if it turns on and operates. If it does, then we'll give it a video signal. Let's make sure our width transistor doesn't short out on anything. Normally there's a frame here that this mounts to with a heat sink, and this thing gets really, really hot. So you never want to run this for longer than a couple of minutes without this hooked up to a heat sink. But yeah, I'm trying to find a place where this will go where I don't worry about it shorting out. There we go. That should be okay. All right. Okay, let's give it power before I make a fool of myself here and say, oh, it doesn't work. There we go. Okay, we got anode, neck, yoke, ground, power, video, and remote board. Remote board is here isolated on the towel so we don't short it out. We're ready to read B+. Hopefully it's around 117 somewhere, which it should be. That's where I set it to before I shipped it out to the original owner. But all right, here we go. What's going to happen? 1, 2, 3. Okay, it comes right to life. It's making a rather odd noise, but it's working. And we're at 117.3. Of course, we have no video, so let's turn this off. That weird noise could be because there's no video signal. You never really want to run a monitor without a video signal. But let's turn that on, or plug that in, I should say. Plug that in. Turn this on, and we need to actually turn it off medium res. On. Okay, let's try again here with a video signal. 1, 2, 3. Oh, it's still making that weird noise. But, oh, it's because we have horizontal hold problems. That's why that... oh, I need to... Let's turn this off. And I need to adjust H hold, which is right here on the chassis. Let's set this in the middle and try this again. And H position is in the middle here on the remote board, so... Okay, that noise is now gone, and we got to adjust vertical hold. Oh, something just shorted again. My isolation transformer is humming. Something just shorted again. I'll bet you if we turn this on, we'll hear this thing hum again. Yep, listen. Something just dead shorted. That MOSFET just shorted again. Oh, interesting, interesting. Well, let's see if we can figure out what's going on now. All right, well, I'm pretty sure I have found part of the problem, if not the problem. We know we blew the MOSFET yet again, so I dug around in my spare parts chassis, and turns out that I've already robbed all this MOSFET from every other parts board that I have. The one that we just installed that we blew up again was the only last one that I had. So I placed an order for some more, so I went through digging on other chassis thinking, well, I wonder if there's another chassis that might have that same MOSFET on it. And the answer is yes. The D9200. Probably 9400 as well, but as you can see here, I got a 9200 here that has been picked pretty clean. All the caps are gone, flyback's gone, all kinds of stuff. But right here in this location, Q413, Q413 is the exact same part number MOSFET that we need. So I was able to find one on this 9200 parts chassis and replace it. So now we can test it again when the time comes. But when I did a cursory look over, when I first got it and found that chip blown up, I did a cursory look over the power supply. I didn't see anything wrong. So we kind of proceeded and changed out the MOSFET and changed out the chip, the U101. And I overlooked this because in my haste to try and figure this out, I overlooked the resistor that's burned up. There's a resistor that's burned up. Now what's odd is that when we run this with just the power supply isolated, light bulb lit up, there were no strange noises, everything seemed to be okay. But once we introduce the B+ back into the system for the output, that's when this problem rears its head. And it's most likely due to this resistor that I overlooked. Now if we zoom in here, it's about as close as I can get. Oh man. This little guy right here, you can even see the burned part of the board here. this resistor underneath here has a big hole blown in the side of it, and all of this is heat from the explosion of the resistor. Now we know we had on the side of this capacitor here from this blowing up residue from the explosion, but right here I overlooked this the first time around on my inspection, and that's my fault. That's why it's the amateur channel. But so I have another replacement MOSFET installed, and it tests good. So what we're going to do is replace that resistor. Now that resistor should read 10 ohms in circuit. If we measure this, that resistor should read 10 ohms in circuit, and we're getting a reading of 861 ohms. So I'm going to remove that, get a replacement from a donor, get that installed, and then we'll come back and see if it reads the 10 ohms. Alright, well that was quick and easy. So I have the resistor that's burned up sitting right here, and it's supposed to read 10 ohms, but if we test it out of circuit, it reads 963 ohms. Oh, come on. 961 ohm. So yeah, that's a far cry from 10 ohms. So if we test the one that I just installed from the donor chassis, which actually came from a U5000, we get 10 ohms. So now it's time to hook this back up to a tube and see if that has improved our situation. Well, no, immediately, because what I was experiencing before was I had a high-pitched noise, like a whine, like a it's hard to describe, like a psst. You could hear it, and then it would start to get lesser and lesser and lesser, and then zap. That's when the MOSFET died. So we'll know if the situation has improved by turning it on. If we don't hear the hiss, then it's more than likely fixed. If we do hear the hiss, I'm going to turn it off because I don't want to sacrifice my last remaining MOSFET. So let's get this hooked back up here real quick. Let's just go. Now the tube I'm using actually had a 7500 on it. So to avoid having to try and adjust everything from that other remote board that I had, I'm going to use a dedicated one that I took off the other chassis that came from the tube that we're using to test this one, because everything should be already set, because it's a 7500 and everything. So I shouldn't have to mess with horizontal hold, vertical size, horizontal position. It should already be set based off of the other chassis being a 7500 as well. Of course, it may not be perfect, but I'm hoping to not have to adjust horizontal hold and things like that and run the risk of possibly damaging this again. So we're going to use one that is known to be good off of another 7500. And let's get this on here and this on here. Now also I slaved in off camera I thought the flyback might have been the issue. So I slaved on another known working flyback. It was used, but I slaved that on there, and I had the high-pitch hissing still, so I shut it down and put the original back on. So I wanted to point that out in full disclosure, in case you noticed that this little wire that runs through the ferrite core and connects to the chassis, it's not needed for operation, so I just take it off whenever I work on these. So if you noticed it was missing, in full disclosure, that's why, because I slaved on another known good working flyback thinking that was the cause of our problem, or the hissing noise. But when I turned it back on and heard the hissing still, I shut it down. So I put the original one back on. So again, if we hear the hissing still, we're going to shut it down. If we don't hear it, then we're going to assume it's okay and we'll let it run for a little bit. And if it zaps it out, then we'll have to be on hold until my replacement parts come in. That being said, I forgot to hook this up. And we still have our width transistor installed, so that should be it. Neck board's fully hooked up, remote board, transistor hooked up to the chassis. Okay, so yeah, let's get this on a tube again and see if it works this time. Alright, all hooked back up. Let's turn on our test pattern generator, and we're still set up to read B+, because if it does work and operate, I want to verify that we can sustain 117. Let's make sure that that's not going to short out on something. We'll just set it like that. Okay. Alright, so we're hoping that it doesn't hiss at us. If it does, we're going to shut it down. So here we go. 1, 2, 3. Oh, gosh dang it. I forgot to plug it back in after last time. Okay. This is actually take 2 for you guys, but 3 for me because of that flyback I changed out. Alright, so let's try this again here with it plugged in now. 1, 2, 3. No hiss. 117.9. And we get a picture, but I'm going to turn this off again because I noticed that when this was burning up the MOSFET, I took it back off the tube and that heatsink was like scorching hot. So I want to verify, oh no, it's ice cold, okay. Let's turn this back on. And I'm just gonna touch the heatsink here and make sure that it's not getting hot. And we do have an image. I don't hear the hiss, so that's good news number one. And the heatsink is not getting hot at all, nice and cool. That's good sign number two. We have a good stable picture. We're at 117.9. The only problem is I don't have, I gotta finagle this out of here. I don't have any of the, I gotta swap these little knobs around for various things here. Let's adjust contrast down a bit. Right there. And let's do brightness up. I gotta turn brightness back down and fly back up a bit slightly here. That's better. Okay. Brightness right there's good. Okay, that's not bad. I got like these little interference lines popping around. Can you see those? I can hear static popping. Could just be the test pattern generator and stuff, so we'll give it an actual video signal later, but let's go through. I'm trying to put this pin back in here. There we go. Let's go through and test RGB. Yeah, we have RGB, but there's this interference going through. Maybe you can you see that? I don't know what that is. Well, we're doing better. Yeah, that's odd. I'm sorry. As I'm trying to figure this out and think, there's these lines going across here that are doing it. And when it's happening, I can hear a little static popping. Well, let's just turn this off and give it an actual video signal from an actual PCB. I have WrestleMania here. I'm working on a WrestleMania project. Get some more light. There you go. I'm working on a WrestleMania project, and I did a conversion on a board. So let's actually hook up this board and see what we can. Actually, you know what? I just totally blanked. This is a medium res. I can't do that. Let's get the Cruisin' USA board and make some adjustments and see if we can get this looking good with the Cruisin' USA. Okay, let's see what we can do here to make this look better. I have the Cruisin' USA hooked up, so let's turn this on. Here we go. 1, 2, 3. And we have 118.2 on the B+, and the test pattern generator, again, the video output is vastly different from a standard JAMA board, so we need to increase our brightness level here. Flyback's too high, we have to go down to right there. Now let's turn our contrast up. Nope, contrast is limited to there. Brightness contrast all the way down. Flyback up right there. Brightness up. Nope. I still got. Let's set our color pots to about 25%. Now let's turn up our brightness. That's better. Contrast. Right there. Can we turn up the flyback anymore? Right there's good. Focus. Turn the contrast back down a little more. And focus isn't that great, but that's probably the picture tube and not indicative of anything else. H position. Okay, now width, we have width control, I can tell you already. Yep, got good width control. Vertical position. Right there, let's go to height. Right there. Well, there you go. It's working. We're at 117.9 on the B+. And I still have the little crackling and the interference. I don't know if it needs to just work itself out or I mean, I can hear a little static, you know, static discharging noises. Like when you run your hand across the screen, you hear this? Oh, got me a little bit. I can hear that. And I have an extra ground going to the tube and the frame of the chassis. And I've got the chassis in the frame and it's screwed in and grounded. But for some reason, let me try something here. I'm going to try something different. Let me put this in a different location. Let's put this here. And I wonder if I can, let me get this screw in real quick, hold on. All right, let's try this again. I moved the screw to a different location. Now I can still hear it making that noise. Yeah, the lines are still there. Well, I mean, it's not necessarily indicative of a problem with the chassis. I want to turn the B plus down a bit, because that could be something with the tube. Yeah, 116.8, 116.9, okay. So B plus is better, that made no difference. I don't know if you can see that, but if you look in here, you can see, it just went away, but you can kind of see the horizontal lines that go up and down. Yeah, I'm not sure what would be causing that. I've got it isolated. I mean, I've got a ground from the frame to the chassis, and the chassis screwed down to the metal frame, of course. It's not really noticeable. No, it's definitely there. Come on, get off the screen. I don't have the controls hooked up, sorry. But you can really see it. Let's go back to the TPG. Now this wasn't doing that the last time I had it. And I don't know if it's a... Let's go to a solid color here. Can you... Nope. Yes, let's go to a white screen. Yeah, this stupid frame refresh rate of this camera is going to put the kibosh on me. It's showing you what's going on here. Maybe you can see it. You can see like there's horizontal lines going up and down like that. It's like a scan. Well, before this width transistor burns itself up, I'm going to remove it because we know that it works. And I don't want it to burn up on me, so let's try this again. 117.0, yeah, okay. And you can see how it's shrunk now. But I don't know if it's coming through on the camera. Maybe you can see those lines going like this. Yeah, I don't know why the refresh rate's doing that. Let me see if I can figure out what's going on causing this, and I'll come right back. Alright gang, well it's a number of hours later, and out of desperation I went ahead and just swapped in a brand new vertical IC, and that fixed my problem of the lines going across the screen that are, well, the lines were going horizontal, but they were flickering vertically up and down. Like the system was trying to full deflection, and it wasn't shrinking, but it was kind of like doing this. The lines going across horizontally were kind of going like this. So I went through painstakingly the entire vertical circuit, verified we had 26.5 volts on the 25 volt line, so no problems there. I checked all the components and resistors and capacitors, everything checked okay. So out of desperation, I swapped in a brand new vertical IC, and that fixed the problem of all the line issues. So we still have a little bit of crackling every so often, but it doesn't affect the image, doesn't seem to cause a problem at all, so I'm not going to worry about it. But yeah, I mean, that was it. The final straw was that. And as we can see on the... meter here. Let's see. I'll just do it this way. Oh, I lied. I had 117.4 and now it's 116.6. It changes depending on what's on the screen, but it's supposed to be 117. We're close enough. We'll see if when the screen changes if it gets back to 117. I was going to show you I had 117.4 and then it changed. So, but close enough. 116.677. There's 117. So 116.9. We're going to call that okay. So this came down to that resistor that was bad was R107. So we had a bad or a flaky vertical IC, a bad R107. Yeah, the IC R107. We had a blown up U101 and a bad MOSFET. I think it was it's Q104. I forget what it is. But 4 bad components. After all that, it's back up and running and works and looks great. It does have a little bit. I went ahead and plugged the width transistor back in just for display purposes here. I don't want to run it too much longer. I'll run the 8-hour burn-in. I'm going to do another 8-hour burn-in to make sure we don't have any drifting focus or brightness. I did that once already when I sent this to the person that had it before. So I'll do it again just to make sure we don't have any drifting focus or brightness. But the focus right now isn't that great. I can't make it any better. So I want to consider that a tube problem. I'm more leaning towards it being a flyback issue. But I don't have a flyback to put in, so it's kind of a moot point. But it does work and operate, and if it doesn't drift focus or brightness, we'll call it good. We had the 4 bad components, and that's about it. There you go, 117.2 solid. So, yeah, let's see if I can grab all the components here. Not that you're going to be able to see them, but let's take you off the overhead here. No, I'm sorry, not overhead. I'm just so used to saying that. We'll take you off the tripod here is what I was saying. And, yeah, vertical IC, flaky, bad MOSFET, blown up U101, and this burned up resistor here. See if we can get a better shot of that burned up resistor. There you go. So 4 bad components, and we're back up and working beautifully. Now I need to put those little standoffs back on because that's, well, I take that back. I may not put them back on. I'll put them in a Ziploc bag and include them back with the chassis because I don't think that they're supposed to be on there. I don't know if they were contributing to the problem, but I don't want to put them back on because they shouldn't be installed. I'm not sure why they're there or what purpose they serve, but I'll let the owner of this figure that out. But yeah, they're going to need to redo all of their brightness and focus and screen position and size and contrast and color pots and all that, of course, as well. But we are good to go. All it'll do is the 8-hour burn-in. All of my lines are gone. Everything is great. Nice and rock solid. So thanks for watching. Hope you learned something. Glad this was able to get worked out. I appreciate it. Like, share, and subscribe, and we will see you next time.